This video will discuss linear models and applications. We're going to specifically look at the first two examples, write an expression in context, and a mixture example. So for our first example here, we want to write an expression that represents this situation. Jason is driving on a long road trip. He currently has 10 gallons of gas in his car, and each hour that he drives, his car uses up 0.8 gallons of gas. How much gas would be in the tank after driving for 3 hours, and how much gas would be left after T hours? So, as always, we should use the information here. So we know T is the number of hours. I'll make this smaller. The number of hours. And we know that every hour he uses up 0.8 of a gallon. So fuel used in T hours is going to be 0.8 T. So if it's 3 hours, it's 0.8 times 3, or 2.4 gallons. All right, so how much gas would be in the tank after driving for 3 hours? Well, his fuel would be the 10 gallons he started with, and we would subtract 2.4 gallons, and that would give us 7.6 gallons. If I'm going to do it for T hours, the fuel is going to be 10 minus 0.8 times T, where T is the number of hours. So this would be a more specific example. This is in general, how much fuel would be left, 10 minus 0.8 T. For this next example, this mixture problem, let me make this nice and big for us. We have a chemist that needs a 20% solution of alcohol. She has a 10% solution and a 35% solution. The question is, how many liters of the 10% solution should she add to the 3 liters of the 35% solution to obtain the 20% solution? So I'm going to start here by identifying my variable. We're going to let L be the number of gallons, or liters, liters of the 10% solution. And I'm using that because that's the question. How many liters of 10% solution should be added? And for this kind of problem, I'm going to write myself a little model so that I can think about what's going on here. So we know we want a 20% solution, so 20%. And we know we have a 10% solution, and we have L liters of that. And we have a 35% solution, and we have 3 liters of that. So if I add L liters to 3 liters, this is going to be L plus 3 liters. And this really is our equation kind of staring us in the face. We know that 10% as a decimal is 0.10 times L plus 0.35 times 3 equals 0.2 times L plus 3. And from there, we'll solve. So we have 0.10 L plus 0.35 times 3 is 1.05 equals 0.2 L plus 0.6. So subtracting 0.6 and also the 0.1 L, we get 0.46 equals 0.1 L. We're going to get x equals L equals 4.6. So we're always going to answer in a sentence here. We would add 4.6 liters of the 10% solution. Okay, I'm going to stop here and start a new video for the next two examples.